Astronomers often describe NGC 3414 as a cosmic chameleon, a galaxy that refuses to fit neatly into the tidy boxes of classification. Unlike the elegant spirals with their graceful arms or the smooth featureless ellipses, this system blends traits from multiple families, earning its reputation as a mutant of the galactic world. At first glance, it appears lenticular, a disc-like structure with a central bulge, yet its surrounding halo and tidal debris tell the story of violent encounters. Streams of faint stars arc outward like ghostly fingerprints of past mergers, wrapping the galaxy in a cloak of distortion that betrays a turbulent history. This stellar hybrid, sometimes called the peculiar lens, lies about 80 million light-years away in Leo. Its light, stretched across eons, carries encoded memories of collisions and assimilations that transformed it into the odd form we see today. Deep exposures reveal tidal shells and arcs, ripple-like structures that are the scars of swallowed companions. Such features suggest that the galaxy has feasted on smaller neighbors, pulling them apart with tidal gravity, weaving their stars into elongated filaments that glow faintly against the cosmic background. Unlike the majestic order of spiral arms, the body of this galactic anomaly is chaotic and asymmetric, its dust lanes warped and its stellar distribution uneven. Its nucleus is classified as a liner, a low-ionization nuclear emission line region, indicating the presence of a central black hole quietly accreting material. This weakly active core may not blaze like the quasars of more violent galaxies, but it hints at a restless heart still digesting matter from its disrupted environment. The result is a galaxy suspended between states, not entirely quiescent, not violently active, a liminal form in the evolutionary spectrum. The strange identity of this cosmic outlier makes it invaluable for science. It is a living fossil of galactic transformation, showing how mergers can twist orderly spirals into lenticular remnants, and how cannibalism reshapes structure and destiny. When telescopes peer deeper, they uncover knots of younger stars mingled with ancient populations, signs that bursts of star formation ignited during collisions before slowly fading into silence. Around it, filigrees of stellar streams whisper of interactions still unresolved, as if the galaxy carries its past as luminous trails etched into space. This distorted lens of stars, sometimes nicknamed the misfit of Leo, lives within a modest galactic neighborhood but stands out as one of its strangest inhabitants. While many galaxies in the Leo constellation present the elegance of spirals or the quiet roundness of ellipticals, this hybrid is a patchwork of dynamical experiments. Observations with the Hubble Space Telescope and ground-based instruments have revealed its faint stellar streams and shells stretching outward like the fading echoes of a symphony. These loops are fossil records of accretion events, frozen ripples on a galactic pond stirred by gravitational intruders long ago. Kinematics show that the stars inside this cosmic renegade do not move with the smooth coherence seen in typical disks. Instead, their orbits are scrambled, some locked into rotating streams, others drifting chaotically, reflecting the scars of disruption. This complex internal structure suggests a violent reshaping not billions of years ago but in relatively recent cosmic times, leaving the galaxy still settling into equilibrium. The dark matter halo that envelopes it provides the invisible scaffolding for these distortions, binding together both native stars and the captured remnants of smaller systems. Astronomers consider this enigmatic lens a case study in how mergers alter galactic destiny. Spirals can be stripped of their arms, their gas reservoirs stirred into turbulence, their cores ignited with transient activity. In the aftermath, what remains is often a smooth lenticular body, but in this mutant form, the transition is unfinished, the process laid bare. By studying its structure, scientists glimpse the pathways by which orderly spirals are transformed into more spheroidal systems, linking the stages of cosmic evolution. Despite its chaotic past, the galaxy continues to harbor a central supermassive black hole. Spectra of its nucleus show signs of ionized gas and low-level accretion, like embers smoldering in the ashes of earlier conflagrations. This central engine may once have been more luminous, possibly triggered during one of its mergers, but now it glows faintly, a whisper rather than a roar. Around it, older stars dominate, painting the galaxy with the redder tones of ancient populations, though patches of bluer light betray younger stars born from merger-driven starbursts. In the realm of peculiar galaxies, this cosmic shapeshifter has earned a place alongside some of the strangest examples known to astronomy. Much like Centaurus A, with its warped dust lanes and enormous radio lobes, or Hoag's object with its near-perfect ring, the Leo Mutant is a reminder that the universe does not follow simple templates. Galaxies are not static portraits, they are dynamic beings, constantly sculpted by the forces of gravity, time, and interaction. This hybrid system demonstrates that the neat categories of spiral, elliptical, and lenticular are only snapshots in a continuum of transformation. One of the most striking features of this oddball is the set of faint stellar shells that wrap around it like the layers of an onion. These shells are created when a smaller galaxy plunges into a larger one, its stars flung into radial orbits that pile up at certain distances, forming arcs of light. Over time, these shells dissolve into the background, but while they persist, they serve as archaeological clues to ancient cannibalism. In this way, the galaxy resembles Centaurus A or NGC 3923, other systems famous for their rippling stellar cocoons. Such structures not only reveal the violence of past encounters but also provide laboratories for testing simulations of galactic dynamics. The dark matter halo surrounding this cosmic anomaly plays a hidden but crucial role in its story. Though invisible, this halo acts as the silent architect of the galaxy's fate, dictating how mergers unfold and how tidal streams are preserved. When smaller galaxies are torn apart, their stars become luminous tracers of the underlying gravitational field. By mapping these faint arcs, astronomers gain indirect glimpses of the dark scaffolding that cannot be seen directly. In the case of this peculiar system, the survival of such structures suggests that its halo is both massive and extended, capable of catching and holding on to debris for billions of years. Comparisons to polar ring galaxies highlight another layer of its strangeness. In some images, the faint arcs of light encircling this object almost resemble the beginnings of a misaligned disk, hinting that one of its encounters may have involved the accretion of gas at an odd angle. Polar rings, such as those in NGC 4650A or NGC 2685, show how material can be captured and stabilized in perpendicular orbits, forming rare geometrical wonders. Though the Leo Mutant does not possess such a grand ring, the chaotic trails of stars around it suggest a kinship with those more exotic specimens. The central bulge of this galaxy is another mystery. Photometric studies reveal that its brightness profile does not align cleanly with a simple disk or spheroid, but with a hybrid of both. This central light distribution, combined with its kinematically disturbed stars, confirms that it is not a settled system. Instead, it exists in a transitional state, a bridge between youthful spirals and the smoother lenticulars that dominate older galaxy clusters. Observing such an object is like catching a caterpillar mid-metamorphosis, its body reshaping before it hardens into a more permanent form. Its nucleus, classified as a liner, gives astronomers further intrigue. Liners are often associated with aging galaxies whose central black holes accrete at low levels. In this case, the faint emission lines suggest that gas stripped from companions has been funneled inward, feeding the black hole at a gentle pace. The result is a galaxy whose core whispers of activity but never screams like a quasar. Yet, even in its subdued state, the nucleus influences its surroundings, heating gas, ionizing clouds, and leaving subtle fingerprints across the spectrum. Taken together, the evidence paints this peculiar galaxy as a survivor, a system that has endured repeated collisions, absorbed smaller neighbors, and reshaped itself into something that defies easy classification. Its story is written across multiple layers: faint shells, twisted dust, disturbed orbits, and a restless nucleus. Each of these features is a sentence in a cosmic chronicle of change, reminding us that the grand narrative of the universe is one of continual transformation. Seen through deep exposures, the Leo renegade looks like a memory in the act of forming. Its main body is smooth and lens-like, yet the outskirts are stitched with gauzy arcs and folded ripples, the kind of low-surface brightness structures that only appear when a larger system swallows smaller ones and the stars from the victim stack up along shared turning points. Each arc is a kinematic breadcrumb. Follow enough of them and you can infer not only the mass distribution of the host but the timing of the encounter that made the ripple. Computer experiments that throw dwarf galaxies into more massive disks reproduce the same onion skin geometry, and the same slow fading as dynamical mixing erases sharp edges over a few orbital periods. From the center outward, this lenticular misfit refuses to behave like a settled disk. Long slit and integral field maps of starlight show that the velocity field twists as you move away from the nucleus, as if different generations of stars remember different rules. Some orbits are nearly circular, others plunging and elongated, and the misalignment between the photometric axis and the kinematic axis hints at a triaxial potential, a not quite round gravitational well shaped by past mergers. In places where faint dust threads cross the bulge, the absorption lanes tilt relative to the main body, a telltale of gas arriving from odd angles rather than condensing peacefully in the original plane. The shell-draped enigma carries a nucleus whose spectrum fits the liner archetype, emission lines from low ionization species that advertise a central engine accreting modestly. That engine is almost certainly a supermassive black hole scaled to the galaxy's central velocity dispersion, a quiet heavyweight more ember than bonfire. Even at a subdued pace, such a core can stir its surroundings, ionizing residual gas, nudging pressure balances, and subtly regulating any leftover star formation that merger shocks once ignited. Star formation histories extracted from absorption features suggest a mosaic, an old, metal-rich population that dominates the luminosity budget, laced with pockets of intermediate-age stars likely born when infalling gas was shocked and compressed. Ultraviolet imaging of the tidal debris often reveals the last sparks of those episodes, blue pinpricks scattered along the streams like campfires in a desert after the festival has ended. The gas reservoir today is meager, typical for transformed disks. Whatever cold material remained after the skirmishes was either consumed in brief starbursts, heated, or expelled. As a laboratory for dynamics, this Leo outlier is unusually generous. The spacing of its shells encodes the gravitational potential, the thickness of each arc traces phase-mixing timescales, and the brightness contrast between adjacent ripples constrains the mass ratio of the encounter. Where the stellar streams curve, planetary nebulae and globular clusters can be used as test particles, measure their velocities and you sketch the invisible scaffolding of dark matter. The resulting portrait tends to favor a massive, extended halo, exactly the kind of structure that can catch and preserve tidal debris for gigayears rather than letting it vaporize into the background. The kinematically tangled waif does not live alone. It sits in a modest association where slow encounters are plausible, the sort of environment in which repeated minor mergers, rather than a single catastrophic smash-up, can gradually erase spiral architecture. In such neighborhoods, galaxies age not by isolation but by assimilation, trading angular momentum for random motion until the original disk forgets its symmetry. The current morphology, smooth core, warped dust, ghostly skirts, looks like a snapshot taken partway through that assimilation, a chrysalis rather than a final form. Compared with canonical peculiar systems, the tidal alchemist is more understated than a classic polar ring showpiece yet more unruly than a pristine S0. It shares with Centaurus A the language of shells and with NGC 2685 the suggestion that matter can arrive on misaligned orbits, but it translates those dialects into a quieter script. Where some galaxies advertise their strangeness with neon, this one writes in graphite and fog. That subtlety is an advantage. The fainter the structures, the more faithfully they remember the past, because they have not yet been stirred beyond recognition. On the theoretical side, the chimeric lens is a stress test for simulations that track both stars and gas. Reproducing its mixed kinematics demands more than a single head-on collision. You need a sequence where angular momenta don't line up, where gas is fed inward in bursts, and where feedback from the nucleus never quite detonates into a full-scale quasar phase. N-body plus hydrodynamic runs that sprinkle in minor satellites on inclined orbits yield the right combination of warped dust, counter-rotating patches, and shell spacing. They also predict a slowly rising central mass-to-light ratio as older, redder stars dominate, consistent with the galaxy's muted colors. Zoom in, and the accretion-sculpted remnant speaks in chemistry as well as motion. Metallicity gradients flatten wherever tidal stirring has mixed the disk, while localized bumps in alpha element ratios mark locations where short, intense starbursts once spiked the enrichment. Even the dust tells on itself, its grain size distribution shifts after shocks, leaving fingerprints in the far infrared that observers use to time the last major disturbance. If the dust lanes look threadbare now, that is because turbulence long ago shredded the larger clouds and left behind finer, more homogeneously mixed debris. The misaligned relic is also a reminder of how black holes and bulges coevolve outside the spotlight of luminous AGN. In a system like this, accretion proceeds in sips rather than gulps. Over long spans, those sips still matter. They keep the central engine warm enough to ionize gas and perhaps launch weak, thermally driven outflows that prevent the immediate recollapse of any cooled material. Such gentle maintenance, feedback in soft focus, can explain why the present-day star formation rate is low without invoking a dramatic blowout. Out in the fringe, the halo carries a second archive, the globular cluster system. Blue, metal-poor clusters often trace an ancient backbone assembled early, while red, metal-rich clusters shadow the bulge and any subsequent starbursts. Count them, map their orbits, and you can read which components were born in situ and which were adopted. In many transformed disks, the outer cluster system is kinematically hotter than the inner one, as if the outskirts remember the jostling hands of mergers more vividly than the core does. The same logic likely applies here, reinforcing the picture of a galaxy stitched from many smaller stories. For observers, the shell-ringed paradox is a challenge in contrast. Its most revealing features hover barely above the night sky's glow. Amateur telescopes under pristine conditions can tease out the brighter arcs, but it takes long integrations on large apertures, or the surgical sharpness of space telescopes, to chart the full lattice of debris. Each added hour of exposure is like brushing away another layer of dust on a fossil. Contours sharpen, new ripples emerge, and the past becomes less hypothetical. As a signpost for cosmic futures, the hybrid outcast offers a quiet prophecy. Given enough time and enough minor accretions, even well-ordered spirals can relax into smooth, gas-poor lenses. Our own Milky Way, destined to tangle with Andromeda, will not end up identical to this object, yet the broad arc of transformation, disks heated, orbits randomized, nuclei fed episodically, echoes the same theme. Galaxies are biographies written by gravity. This one just left more of its drafts in the margins. In the end, the Leo anomaly is compelling precisely because it is unfinished. Its shells have not yet dissolved into invisibility, its kinematics have not yet aligned into a single, forgetful equilibrium, and its core has not yet gone completely dark. It is a living time machine that lets astronomers watch metamorphosis mid-spell, a place where the tidy textbook sequence of spiral lenticular elliptical blurs into a richer grammar. To study it is to admit that the universe edits constantly, and that the most truthful portraits of galaxies are sketched while the paint is still wet. Push the exposure deeper and the misfit of Leo turns into a tidal palimpsest. What looks smooth at casual glance resolves into an embroidery of structures riding on different clocks, inner stars that complete an orbit in a few 100 million years, outer streams that need billions, and shells whose edges sharpen where those clocks momentarily synchronize. In simulations, this phase wrapping produces the same nested arcs seen around the lenticular chimera, with their spacing quietly encoding the mass profile of the host. Read them carefully and you extract a history, how radial the intruder's plunge was, how massive the encounter, how long ago the splashdown happened. Integral field spectroscopy paints the wayward lens as a kinematic jigsaw. Inside one effective radius the velocity field twists, and beyond it the dispersion swells where overlapping orbit families crowd together. It is the signature of a triaxial potential. The gravity well is neither perfectly round nor simply disk-like, and of stars inherited from multiple progenitors. Some patches even look like a kinematically decoupled core, a central enclave whose stars rotate on a misaligned axis. The fossil of gas that once streamed in along a tilted plane, formed stars, and froze its own memory into motion. In places, the ionized gas refuses to follow the stars at all, preferring orbits set by the last accretion event. That misalignment is dynamical graffiti left by merger geometry rather than calm, in-plane cooling. Across the spectrum the shell-draped enigma keeps yielding clues. In the ultraviolet, faint beads of recent star formation hang along debris where shocks briefly compressed gas. In the mid-infrared the dust glow is modest, suggesting the remaining cold reservoir is thin, typical for transformed disks whose gas was either consumed in merger-triggered bursts or heated and stirred beyond easy collapse. At 21 centimeters, extended neutral hydrogen is scarce or displaced, another hint that tides and ram pressure from the local medium have rearranged the pantry. X-ray images mostly show the pointiest light of old binaries with perhaps a whisper of soft diffuse gas, nothing like a blazing, cluster-scale atmosphere, consistent with a system evolving by slow, repeated nibbles rather than a single cataclysmic smash. Spectral fingerprints turn the tidal paradox into a population mosaic. Lick index measurements and full-spectrum fits describe an old, metal-rich backbone with supersolar, alpha/Fe, near the center, evidence for brief, intense star formation long ago, overlaid by intermediate-age pockets in the outskirts where streams cross. Metallicity gradients are flatter than you'd expect for an untouched spiral, as if a cosmic spoon had stirred the pot. Where shocks once tore through clouds, alpha elements spike in tiny plateaus. Where dust lanes have thinned, the far IR slope hints at grain processing by turbulence and time. At the very heart, the peculiar lens hosts a restrained engine. Its nucleus wears the badge of a liner, low ionization lines that point to a supermassive black hole accreting in sips. That is enough to keep ambient gas warm, discourage wholesale cooling, and sustain low-level outflows, but not enough to ignite a quasar. Maintenance mode, not demolition. Over gigayears, such gentle feedback can explain why the present star formation rate is low without invoking a dramatic blowout. The center stays just energetic enough to prevent a full reset. The halo is the true archivist. Globular clusters orbit through the outskirts as bright, countable tracers. The blue, metal-poor population maps the ancient framework assembled early, while red, metal-rich clusters echo later, more dissipative episodes. Measure their velocities and you weigh the dark matter scaffolding that cradles the entire structure. Planetary nebulae offer a second set of beacons. Their narrow oxygen lines are easy to catch against the night, letting astronomers chart the velocity field far beyond where starlight alone is practical. Stitch those measurements together with Jeans or Schwarzschild models and a consistent picture emerges, an extended halo that is massive enough to keep tidal debris coherent for a long time, but not so deep that all signatures are erased quickly by violent relaxation. Environment sets the tempo for this oddling. It inhabits a small association where galaxy speeds are modest, the perfect breeding ground for repeated minor mergers, harassment, and slow gas starvation. In such neighborhoods, disks fade not by loneliness but by assimilation. Interactions trade ordered rotation for random motion, thicken the stellar body, and exhaust or heat the gas that would otherwise build fresh arms. The result is precisely this half-remembered disk, a whirl-less body with a smooth face and a haunted periphery. For observers, the tidal palimpsest demands patience and craft. Its most telling structures hover at surface brightnesses fainter than 28 to 29 mag arcsec superscript 2, where imperfect flat fielding, scattered light, and sky subtraction can forge false ghosts or erase true ones. Long integrations, careful dithers, and aggressive control of internal reflections are not optional but existential. Each additional hour of exposure peels back another layer, arcs that were guesses turn into curves you can trace, and streams you suspected become highways for kinematic probes. On the theoretical side, the chimeric S0 is a truth serum for simulations. It resists explanation by a single, head-on merger, reproducing the mixed kinematics, misaligned gas, and shell geometry usually requires a sequence of encounters with varied orbits and mass ratios. Hydrodynamic runs that dribble in satellites along inclined paths naturally yield warped dust, counter-rotating pockets, and a liner-like nucleus that never quite tips into a high accretion phase. They also predict a slow, inside-out rise in mass-to-light ratio as aging stars dominate, just what the muted colors and elevated central dispersions imply. Even timing the last big disturbance is possible if you take the cosmic seismology seriously. Shell edges sharpen where stars on radial orbits pile up at apocenter, the spacing between them scales with the orbital period in the host potential. Fit that spacing, fold in the observed dispersion, and you get a clock that reads, a few dynamical times ago. Not yesterday on cosmic scales, but not so ancient that phase mixing has dissolved the evidence. That intermediate age is precisely why the wayward lens is so instructive. We catch it in mid-metamorphosis rather than eulogizing a finished form. Projecting forward, the rippled relic's fate is quiet convergence. As the brightest streams dissolve into the background and any remaining gas trickles inward or drifts away, the body will settle into a smoother, more forgetful lenticular. The nucleus may dim further, the metallicity gradient may continue to flatten, and the kinematic twists may relax toward a single dominant axis. Decades from now in telescope time, but hundreds of millions of years on the galaxy's clock, the misfit of Leo will look less like a confession and more like a polished alibi. Yet for now, the tidal palimpsest keeps its marginalia intact. It reminds us that morphology is grammar, not law, that dark matter is the silent author whose plot is revealed by the orbits of faint tracers, that black holes can shepherd evolution with a nudge rather than a blast. Above all, it shows that galaxies are not categories but biographies. The peculiar lens is a chapter where the handwriting changes mid-page, where edits and crossings out are still visible, where the meaning is richest precisely because the story is unfinished. Push closer to the threshold of darkness and the Leo chimera reveals subtler signatures, isophotes that twist with radius, a quiet cue that the underlying mass is triaxial, and a faint skewness in the light profile where shells pass behind the main body and briefly brighten its outskirts. Photometric decompositions that try to force this rebel into tidy bulged disk molds inevitably leave structured residuals, the image processing equivalent of a raised eyebrow. Subtract a smooth model and the page margins fill with handwriting, arcs, spurs, and wisps, none of which belong to a settled, razor-thin disk. Even the central brightness slope resists a single textbook Circic curve, as though different epochs of assembly have stacked their own layers of starlight, each with a distinct memory for how steep or shallow a galaxy ought to be. In kinematic space, the chimeric lens behaves like a city built over older cities. Cold, nearly circular orbits course through parts of the inner body, but only a few hundred parsecs away the velocity ellipsoid fattens, and random motions dominate. The misalignment between the photometric major axis and the rotation axis is a smoking gun. The potential is not axisymmetric, and some stars are streaming along paths inherited from progenitors that approached on inclined or even polar tracks. Where ionized gas survives, it draws its own map, sometimes counter-rotating, sometimes nearly at rest, an honest cartographer of the last gas-rich accretion rather than a faithful follower of the stellar streets. Multi-wavelength views keep deepening the portrait. Far ultraviolet pinpricks mark the places where merger shocks briefly compacted gas into dense knots, now fading toward quiescence. In the near-infrared, the old, red backbone dominates, unveiling the true shape of the stellar mass without the cosmetic noise of short-lived blue stars. At longer infrared wavelengths, the dust continuum is soft and unassuming, more ember than flame, consistent with a pantry largely emptied by past starbursts or heated into a phase reluctant to collapse. Radio maps at 21 centimeters struggle to find a grand reservoir, Any neutral hydrogen that remains appears scant, rearranged, or exiled to the periphery by tides. Treat the misfit of Leo as a seismograph and the shell pattern becomes a timepiece. Stars launched onto radial orbits during a merger pile up at apocenter, their densities cresting into nested arcs whose spacing reflects the host's mass profile and the time since impact. Measure those intervals, fold them through dynamical models, and an era emerges, not so young that the debris is razor-sharp, not so old that the ripples have fully dissolved, an in-between age where phase wrapping is vivid and instructive. In that window, even small differences in shell curvature and thickness reveal whether the intruder arrived headlong or skirted in on a grazing pass. The hybrid's globular cluster system adds footnotes to the chronicle. Blue, metal-poor clusters roam far out, relics of the earliest scaffolding assembled when the universe was denser and rougher. Red, metal-rich siblings huddle closer to the bulge, echoing later, dissipative episodes when gas pooled and formed stars in surges. Their velocities, easy to sample with narrowband filters and efficient spectrographs, become tracer bullets for the dark matter halo. Stitch cluster and planetary nebula kinematics into genes or orbit superposition models and the invisible architecture takes shape, an extended halo that is deep enough to keep streams coherent for gigayears, yet not so violent as to erase their memory overnight. If the lens-shaped renegade once hosted a bar, hints of that past may linger in subtleties, boxy isophotes, faint X-shapes in the residual light, or small, sigma drops where bar-driven inflows cooled and formed stars with unusually ordered motions. Even without a surviving bar, the consequences of past non-axisymmetric structure remain, resonances that trapped orbits, inner rings that were half-built then shredded, and nuclear spirals that shepherded gas toward the black hole in fitful episodes. Each trace is a fossil of angular momentum being shuffled, the quiet work by which disks thicken and memory smears from rotation into dispersion. Chemistry plays historian. Abundance ratios that trend toward enhanced alpha elements near the core point to short, intense star formation timescales early on, while flatter metallicity gradients across the body betray thorough mixing by tides. In the debris, localized metallicity plateaus and irregular dust-to-starlight ratios mark places where the intruder's material still speaks in its own accent. Grain-size diagnostics in the far infrared suggest that shocks once shattered larger dust into finer fragments, leaving a smoother, more homogeneously mixed residue that radiates gently instead of blazing. At the center, the shell-draped enigma runs on maintenance mode. A liner-like spectrum says the supermassive black hole is sipping, not gulping. Photoionization and weak, thermally driven breezes keep the surrounding gas just warm enough to resist collapse. This is feedback as a thermostat rather than a storm, precisely the kind of low-key regulation that can keep a galaxy's star formation rate pinned near zero without the spectacle of jets punching kiloparsec holes or quasar winds raising the pantry. Over long times, the integral of small accretion events still grows the black hole and polishes the cusp of the central light profile. Environment tunes the dance. The Leo outlier inhabits a mild traffic neighborhood where relative speeds are low enough for minor mergers and repeated flybys to matter. In such places, the path from spiral to lenticular doesn't require a single, catastrophic smash. Instead, a series of unspectacular encounters heats the disk, nibbles away at gas, and trades ordered rotation for randomness. Gas starvation from the group medium may do the rest, remove the fuel, and the dynamo of spiral arm regeneration stalls, leaving behind a smooth, anodyne face and a haunted periphery. For observers, the stitched lens is an exercise in discipline. Its telling structures live in a regime where sky subtraction errors masquerade as features, where reflections inside the optics write bright lies, and where flat field imperfections sculpt fake rivers of light. Success demands long integrations, clever dithers, and amongst patience in processing. But the payoff is exquisite, curves of debris you can follow like rivers across the frame, streamers that thread behind the main body and reappear, slightly dimmer, like a whispered refrain, shell edges that sharpen as the signal builds, turning conjecture into cartography. Numerical experiments treat the aberrant S0 as a benchmark. Runs that sprinkle in a sequence of satellites on misaligned orbits reproduce the collage of traits: warped dust, gas, star misalignment, shell spacing, and a nucleus that never quite climbs into a quasar phase. Add in a moderately triaxial halo and the isophote twists fall out naturally. Let the ensemble evolve for a few dynamical times and the inner velocity field begins to unwind toward a single dominant axis, while the outer debris fades into the textbook smoothness of a classic lenticular. The very future the ripple-marked remnant is quietly approaching. Project the story forward and the tidal palimpsest trends toward serenity. Streams diffuse into the background, metallicity gradients flatten further, and any lingering pockets of cold gas either trickle inward to be warmed by the nucleus or evaporate into the group medium. The black hole will keep its ember-bright diet, the central dispersion profile may relax, and the photometric residuals will simplify as the most delicate filigree crosses below detectability. The misaligned relic will look less like a confession of past violence and more like a polished ellipsis, an object that hints at history without displaying the footnotes. Yet today, the chimeric S0 remains a classroom with the lights on. It teaches that morphology is a verb, not a noun, that dark matter's handwriting is legible in the orbits of the faintest tracers, that black holes can supervise evolution with nudges rather than edicts, that the universe edits its drafts in public if you take long enough exposures to watch. The cosmic chameleon is not an exception to the rules, it is the rule revealed at an awkward, invaluable midpoint, when the paint is still wet and the brushstrokes of gravity are easiest to read. Push the modeling further and the leonine shapeshifter becomes a case study in orbital archaeology. Build a library of thousands of possible stellar paths, short-axis tubes, long-axis tubes, box orbits, and let an orbit superposition code assign weights until the composite light, velocity, and dispersion fields match the data. The best-fit solutions rarely choose a single family, they favor a mixed constitution with moderate anisotropy, beta rising with radius as random motions take over from rotation. That gradient is exactly what you expect when a disk has been heated by multiple minor encounters rather than pulverized by one spectacular crash. Treat the lenticular oddball as a laboratory for isophotal diagnostics and its contours start to speak. The A4 parameter toggles between slightly boxy and slightly disky with radius, a fingerprint of embedded substructures, maybe a faded bar remnant inside and shell light contaminating the outskirts. Ellipticity doesn't simply climb and plateau, it meanders, hinting at a triaxial figure whose intrinsic axes are unequal and misaligned with the line of sight. Even the position angle twists by a few degrees, a quiet confession that the mass distribution is not a classical, coaxial bulge plus razor-thin disk but an asymmetric relic still remembering its last ingestion. In population space the merger mosaic looks like a quilt stitched from different epochs. Single stellar population fits label the core as old and alpha-enhanced, rapid early enrichment, while the intermediate radii host stars with ages of a few gigayears, plausibly sparked when misaligned gas flows shocked and cooled during accretion. H-beta absorption strengthens gently outside the bulge, MGB, and fade drift in step with a flattened metallicity gradient, and the resulting maps resemble the aftermath of mixing by tides instead of the crisp gradients of an untouched spiral. Where debris arcs cross the main body, tiny plateaus in alpha/phi, red like notes left by the intruder's chemistry. The nonconformist of Leo is dim in cold gas, but not mute. Any lingering neutral hydrogen prefers the outskirts, where tidal forces shepherded it into ragged filaments. CO searches find only wisps of molecular gas, consistent with a pantry emptied by earlier starbursts or warmed above the threshold for collapse. The mid-infrared continuum is soft and spare, more indicative of processed dust grains than lavish reservoirs, while far-infrared slopes betray grains that have been shock-shredded into smaller sizes, a memory of turbulence now long faded. Kinematically, the composite relic hints at a small, misaligned core that rotates faster than its surroundings, a kinematically decoupled component that could have formed when a last trickle of gas settled along a tilted plane and formed stars. Around that enclave, The velocity dispersion rises rather than falls, evidence that orbital families interweave and that the gravitational potential is not simply the sum of a spheroid and a cold disk. Ionized gas refuses to cooperate with the stars, sketching its own rotation axis set by the most recent accretion geometry, a stubborn cartographer ignoring the older street grid. The halo keeps the ledger. Blue, metal-poor globular clusters range wide, tracing the oldest skeleton. Red, metal-rich clusters cling nearer the center, echoing later, dissipative episodes. Planetary nebulae pepper the outskirts with monochrome beacons, their O3 lines bright enough to clock velocities far beyond the effective radius. Feed both tracer sets into genes analyses or orbit libraries and the dark scaffolding emerges, an extended, moderately concentrated halo that explains why shells persist for gigayears instead of dissolving in a handful of orbits. As an environmental product, the hybrid lens fits the script of group preprocessing. In slow neighborhoods where relative speeds are a few hundred kilometers per second rather than 1,000, encounters last longer and angular momenta don't average out. Disks are heated by a series of glancing blows, gas is siphoned or stirred, and arm-regenerating density waves run out of fuel. The endgame is a smooth, gas-poor body with low specific star formation and a history written faintly in the periphery, a description that matches the Leo Maverick almost too well. The central engine of the tidal scrapbook works on a thermostat. Liner-like emission lines say the black hole is accreting in a radiatively inefficient mode, adding heat without fireworks. That gentle maintenance keeps the immediate surroundings warm enough to resist wholesale collapse, preventing the reignition of a bright disk while avoiding the collateral damage of quasar-scale outflows. Over long spans, this slow diet still grows the black hole and gradually steepens the central light profile, but the growth is measured in decimal places, not exponents. For observers, the merger palimpsest is a masterclass in low-surface brightness discipline. Faint arcs near 29 mag arcsec superscript 2 demand meticulous sky flats, careful baffling to suppress internal reflections, and dithering strategies that smear detector artifacts into insignificance. Stacked integrations transform suspicion into geometry, a thread that seemed illusory becomes a continuous curve, a suspected spur connects to a larger loop, a ripple hidden by scattered light stands up when the background is tamed. Narrowband filters tune to O3, and H-alpha turn planetary nebulae and ionized knots into crisp targets for multi-object spectroscopy, extending the kinematic map to radii where starlight alone would fail. Numerical experiments give the S0 renegade a plausible biography. Start with a spiral of moderate mass. Feed it 2 or 3 satellites over a few gigayears, mass ratios of 110 to 120, on inclined orbits. Allow a weak bar to form and fade as dynamical friction and gas loss thicken the disk. Introduce a final, slightly more radial accretion that seeds shells and delivers a modest dose of gas on a misaligned plane. Let the central black hole sip rather than gorge. Evolve for several dynamical times. The outcome, warped dust, gas-star misalignment, triaxial isophotes, nested shells, low specific star formation, and a liner nucleus, resembles the Leonine anomaly with striking fidelity. The oddball's future trends toward amnesia. As streams diffuse and the phase-wrapped shells smear into invisibility, the photometric residuals will quiet, the position angle twists will relax, and the velocity field will drift toward a single dominant axis. Globular cluster kinematics will continue to anchor the mass profile, but the most delicate filigree will slip below detectability, leaving behind a textbook S0 whose violent adolescence is legible only to extremely deep exposures. If an occasional dwarf still strays too close, its stars will be recruited into the outskirts without disturbing the calm, more footnotes than new chapters. Yet, even as it settles, the kinematic patchwork remains a touchstone for theories that try to link black hole growth, gas exhaustion, and morphological transformation. It demonstrates that galaxy metamorphosis need not rely on grand catastrophes. A doctrine of small, well-placed nudges can sculpt structure just as effectively. It shows that dark matter's shape is not an academic curiosity but a practical influence, governing how debris wraps and how long memories persist. And it reminds us that classification is only shorthand. The peculiar S0 is not an exception to tidy rules so much as evidence that the rules are averages over messy, individual lives. Push the analysis one step outward and the outskirts begin to converse with the cosmic web. Faint, linear wisps that align with larger-scale structure hint at anisotropic infall, preferred directions along which satellites arrived and gas once streamed. Align those features with the orientation of neighboring galaxies and you often find coherence on scales far beyond a single halo, a whisper that the merger history of this quiet-looking object is entangled with the scaffolding of the universe itself. In the end, the leonine shapeshifter earns its nicknames because it refuses to be a single thing. It is a lens without perfect symmetry, a disk without spirals, a spheroid with memory. It is a book whose margins are crowded with edits, shells tracing epicenters, dust lanes tilted against the grain, clusters and nebulae marking orbits through an unseen potential. To read it well is to slow down and let faint light do the talking, to accept that the universe writes its biographies in drafts, and that the most instructive pages are the ones where the revisions are still visible. Treat the Leo chameleon as a stability experiment and the physics becomes concrete. A beefed-up bulge raises the epicyclic frequency and boosts the tumor Q of whatever cold gas remains, a recipe for morphological quenching. Even without a dramatic purge by jets or winds, the thickened central mass makes it harder for spiral instabilities to grow. The result is the visual calm of a lenticular face masking a history of turbulence. The disk has not forgotten how to form stars, it has simply been stabilized into silence. If the mutant lens ever hosted a grand bar, its afterimage likely lingers in kinematics rather than in obvious light. Subtle box/peanut hints in isophote residuals and small sigma drops can betray past bar-driven inflows that ferried gas inward on X1 orbits, then spun up a compact, younger component on a tilted plane. When those inflows ebbed and the gas supply thinned, the bar faded, leaving a kinematically decoupled enclave whose rotation axis does not fully agree with the outer body. The shell-embroidered remnant is also an archive of scattering events. Each minor merger trades a little ordered rotation for random motion, pushing the anisotropy upward with radius. Orbit libraries that fit the velocity field tend to blend short-axis tubes with box orbits in the outskirts, exactly what you'd expect if satellites arrived on varied, misaligned paths. That mix naturally explains why the photometric position angle twists gently, why ellipticity meanders with radius, and why the ionized gas draws a map of its own rather than following the stellar streets. Chemistry adds a quiet second voice. Alpha enhancement near the core marks fast, early enrichment. Flatter metallicity gradients across the body speak to tidal stirring that smeared out the sharp contrasts of a pristine spiral. Along debris lanes, localized plateaus in alpha/Fe, red-like accents preserved from the swallowed companion, while far-infrared slopes suggest grain populations processed by shocks, larger dust shattered into finer fragments that now radiate like embers rather than torches. The tidal scrapbook's distance can be cross-checked by multiple rulers. Surface brightness fluctuations in the red/near IR capitalize on the graininess of unresolved stars, delivering a smooth, geometric-like gauge for quiescent systems such as this. Planetary nebula luminosity functions offer a second yardstick, their bright end cutoff acting as a standard candle while simultaneously extending kinematics well beyond the effective radius. When those methods converge, they lock down the scale on which streams arc and shells repeat. On radio and sub-millimeter dials the hybrid S0 speaks softly. Neutral hydrogen is scarce or shunted to ragged filaments, molecular gas, when detected, arrives as wisps and knots. That scarcity is consistent with a pantry emptied in merger-triggered bursts or warmed into a phase reluctant to collapse. Without a cool reservoir, the disk cannot easily regenerate arms, even if densities rise locally. The raised Q and gentle AGN thermostat nudge the gas back from the brink. The shell-draped S0 is a superb dark matter seismograph. The curvature and spacing of its ripples measure the potential. Globular clusters and planetary nebulae fly as bright tracer bullets through the invisible well. Fit their velocities with genes or orbit superposition models and the halo emerges as extended and moderately concentrated, deep enough to cradle debris for gigayears, not so violent as to erase it in a handful of orbits. That balance is precisely why the galaxy is such a pedagogical sweet spot. Memory persists without overwhelming the present. In the soft X-ray, the chimeric lens is modest. Point sources from old binaries punctuate a faint glow rather than bathing the system in cluster-like gas. That quiet is another environmental clue. The object lives in a low to moderate density neighborhood where slow encounters, mild harassment, and starvation by the group medium can reshape disks without the brutal ram pressure of rich clusters. Transformation here is cumulative, not catastrophic. Deep imaging turns technique into truth. Features at 28 to 30 mag arcsec superscript 2 live where sky subtraction, ghosts, and flat field errors love to lie. Long integrations, careful baffling, aggressive dithers, and meticulous background control are less nice to have than mission critical. Stack enough clean frames and conjecture hardens into cartography, a spur becomes a loop, a suspected break connects into a full shell, and a filament you only guessed at reveals a continuous path behind the main body and back out again. The Leonine outlier also lets theory meet data at human timescales. Cosmological zoom-ins that sprinkle in 110 to 120 satellites on inclined orbits naturally reproduce the same collage: warped dust, star-gas misalignment, nested shells, a kinematically quirky core, and a nucleus that idles in a radiatively inefficient state. Let the simulation run for a few dynamical times and you watch the same slow unwinding predicted for the real system. Twists relax, dispersion dominates the outer body, and the faintest filigree fades beneath detectability. Even the star clusters carry a chorus line of history. Color bimodal globular systems, blue metal poor roamers and red metal rich homebodies, encode the timeline of accretion versus in situ growth. Their spatial distributions and anisotropies map which parts of the halo assembled early and which were quilted on later. In many transformed disks, the outer, bluer population is kinematically hotter, remembering the jostle of mergers more vividly than the red inner clan, a pattern the Leo misfit is primed to echo. As a laboratory for black hole scaling relations, the peculiar lenticular is a useful restraint. A linear nucleus implies low Eddington ratios, but the central velocity dispersion still ties the black hole mass to the bulge through familiar correlations. Slow, steady feeding, more sips than gulps, accumulates over gigayears, subtly sharpening the cusp of the light profile without ever lighting the beacon of a quasar. Project the future of the stellar chimera and the arc is toward amnesia with trace elements. Shells will phase mix into a diffuse haze, metallicity gradients will flatten by small, persistent degrees, and the position angle twists will relax as orbital families settle into a dominant axis. Any stray dwarf captured along the way will be stitched onto the periphery like a new footnote, but the main text will read ever more like a classical S0, smooth, gas-poor, and politely forgetful. Yet the present is the most instructive frame. The asymmetric lentil is caught in the middle of an edit, its margins still full of corrections. It demonstrates how bars can form and fade, how minor mergers can heat and thicken, how dark matter sculpts memory, and how black holes can supervise the transition with a thermostat rather than a flamethrower. It shows that galaxies are verbs disguised as nouns, processes we insist on naming as objects. Stand back and the lesson is simple and generous. The hybrid S0 is not a violation of classification, it is the reason classification must be flexible. Its shells are clock faces, its clusters are signposts, its dust is a diary, and its nucleus is a dim pilot light keeping the system warm enough to stay quiescent. The more patiently we look, the more plainly it says, evolution is continuous, memory is faint but measurable, and the universe does its finest teaching in the low-contrast edges where stories are easiest to miss. Push beyond the familiar diagnostics and the Leo Maverick turns into a proving ground for nearly every tool in extragalactic astronomy. Velocity fields from integral field units can be decomposed into harmonic terms, and the higher-order coefficients, the h3 and h4 of the line-of-sight velocity distribution, betray non-Gaussian wings where overlapping orbit families coexist. In the inner kiloparsec of this off-axis lens, an anti-correlation between h3 and v/sigma would point to a diskier subcomponent embedded in a rounder body, while positive h4 pockets hint at radially biased orbits delivered by past accretion. Those subtle shapes in the spectra are time capsules. You don't need to see the intruder anymore to prove it was there. The asymmetric lentil also stress tests angular momentum metrics. The luminosity-weighted spin parameter lambda_r, measured across effective radii, can place the system among fast or slow rotators, but the classification hides nuance. A chimeric S0 can present as a borderline fast rotator inside one r_e while its outskirts are dispersion-dominated, a sign that heating by minor mergers thickened the disk and diluted coherent motion. Radial profiles of lambda_r that rise, stall, and then decline are entirely natural for a body knitted from misaligned pieces. They are the kinematic handwriting of an object that was spun up, stirred, and then steadied. Look at the distorted lens through the lens of scaling relations and more clues emerge. On the mass-size plane, it sits where quenched disks gather. On the fundamental plane, it follows the tight relation of early types but with a mass-to-light ratio that quietly increases toward the center, as older, metal-rich stars dominate the light and dark matter contributes modestly within r_e. Compare its faded Tully-Fisher residuals to spirals and you'll find the offset expected for a disk that lost gas and luminosity while keeping much of its rotation until heating and misalignment began to take over. Where the shell-sheathed relic meets the interstellar medium, the physics is small-scale and decisive. The remaining gas feels an elevated shear and epicyclic frequency. The tumor Q passes the stability threshold. Turbulence and low-level AGN heating maintain pressures that oppose collapse. Magnetic support and a dearth of cold molecular reservoirs finish the job. Star formation doesn't stop because the galaxy forgot how. It stops because too many gatekeepers say, "Not now." If the post-spiral revenant ever flirted with prolate or minor axis rotation, that oddity would likely hide at larger radii where debris orbits along the long axis of a triaxial halo. Long slit cuts aligned with different position angles can catch such behavior, weak rotation where you expect none, or none where you expect some. Couple that with isophote twists and you have a triangulation of shape, evidence that the potential itself is skewed, not merely the luminous skin. The globular cluster chorus adds a statistical backbone. Blue clusters, older and poorer in metals, roam in wider, hotter distributions and remember the assembly of the earliest scaffold. Red clusters, richer and more centrally focused, echo later dissipative events. Their color histograms are often bimodal, but their kinematics can be trimodal when you add tidal debris to the mix. Map their velocities with multi-object spectroscopy and fold in planetary nebulae to extend reach, then feed both into action space models that separate components by orbital character. The outcome is not just a mass profile but a family tree of orbits, who was born here, who immigrated, and who still travels the long way around. Deep imaging of the Leo stray is a technical art. Low surface brightness structures live where systematics multiply, sky gradients masquerade as streams, scattered light paints false halos, and flat field imperfections turn into phantom rivers. The cure is redundancy and rigor, rotating the field, changing roll angles, building night sky flats, modeling pupil ghosts, and validating with independent instruments. When the residuals shrink, the genuine filigree stands up, loops that close, fans that feather outward, spurs that reappear behind the body with just the right dimming. Each successively deeper exposure is like an extra page of margin notes becoming legible. For the anomalous S0, future facilities sharpen every angle. A wide-field survey such as Rubin will catch ultra-faint plumes and satellite knots, timing the last major disturbance more precisely through shell spacing statistics. Euclid and Roman will deliver homogeneous shape and color maps to R_E scales that allow robust stellar population gradients and weak lensing context. JWST can isolate thermally pulsing AGB stars in the nearest streams to pin down intermediate age bursts, while ALMA and, later, the YNGVLA can decide whether the molecular pantry is truly bare or simply diffuse and elusive. SKA Pathfinder HI mapping will test for exiled atomic gas beyond the optical edge, the ghost of a disk that once was. On the theory side, the galactic chimera is a classroom for distribution function thinking. Orbit libraries and made-to-measure models can be phrased in action, angle space, letting you tag debris by its conserved quantities and follow how phase wrapping paints shells. A sequence of 110 to 120 satellites on inclined orbits naturally yields the observed recipe: kinematic misalignment, triaxial light, shell nesting, weakly active nucleus, and a spin profile that rises and then softens. Introduce a modestly cusped dark halo and the persistence of streams over gigayears follows. Flatten the cusp and the debris geometry shifts in ways you can check against the data. Chemistry keeps offering ground truth. The core of the peculiar lens tends toward alpha enhancement and supersolar metallicity, a fingerprint of short formation timescales and efficient enrichment early on. The outskirts exhibit flatter gradients, tidal stirring as the cosmic spoon, and localized plateaus where the intruder stars still speak their native dialect. Dust SEDs imply grain processing by shocks, favoring smaller particles that radiate gently. Even the ionized gas line ratios argue for a soft photoionizing field with contributions from old hot stars and a low Eddington nucleus, maintenance mode, not fireworks. As an environmental story, the hybrid lens reads like group preprocessing writ small. Without the brutal ram pressure of a rich cluster, transformation is cumulative, gentle harassment, repeated flybys, gas strangulation, and a slow trade of rotation for dispersion. The end product looks quiet and unremarkable until you turn the contrast way down, then the margins bloom with memory. It is precisely this balance, present-day calm with archival turbulence, that makes the object such an efficient teacher. Project the shell-embroidered remnant forward and the narrative trends toward serenity. Streams fade into the background, the lambda_r profile smooths, metallicity gradients relax a little more, and the nucleus keeps its pilot light on. A wandering dwarf may add a new footnote, but no fresh chapter is likely unless a gas-rich companion arrives on a finely tuned orbit. Absent that, the orphaned disk will crystallize into a textbook lenticular, its past legible only to those who know how to read the faintest glyphs in the sky. Stand back and the message of the Leo anomaly is almost embarrassingly clear. Galaxies are not categories, they are verbs. The misfit of Leo, the shell-draped enigma, the tidal palimpsest, the leonine shapeshifter, whatever nickname you give it, exists to show that structure is a consequence of history, that dark matter writes its plot in the paths of faint tracers, that black holes can govern with a thermostat rather than a blowtorch, and that the finest astrophysics often hides a hair's breadth above the noise. Push into the outskirts where starlight thins and the Leo outlier turns into a ledger written at the edge of detectability. There the surface brightness falls below the comfort zone of ordinary imaging, yet the geometry grows clearer, shells that pinch toward the minor axis, streamers that arc and briefly vanish behind the main body only to reappear with the right amount of dimming, fans that feather outward where phase-wrapped orbits crest at apicenter. Each curve is a constraint on the gravitational potential, each break in slope is a timestamp on the last encounter. Treat those contours as equations and the mass profile begins to solve itself. Closer in, the stellar kinematics of the cosmic chameleon describe a layered city. Cold, nearly circular orbits trace a faint inner disklet, a few hundred parsecs beyond, dispersion swells and the velocity ellipsoid fattens, announcing the transition to a hotter, merger-heated structure. The anticorrelation of H3 with V/sigma in the inner kiloparsec suggests a disky subcomponent embedded in a rounder host, while patches of positive H4 betray radially biased orbits, smoking guns for accreted stars that dive and linger on stretched paths before turning back. None of this requires a showy collision. A sequence of inclined minor mergers paints the same kinematic quilt with fewer theatrics and more persistence. The shell-wreathed S0 tells its chemical story with quiet emphasis. Near the core, alpha enhancement sits above solar, implying rapid early star formation that ended before Type Ia supernovae could dilute the signature. Intermediate radii host stars of a few gigayears, plausibly born when misaligned gas flows compressed during flybys and settled into short-lived rings. Farther out, metallicity gradients flatten as if stirred with a cosmic spoon, localized plateaus in alpha/Phi, along debris lanes read like accents from the swallowed companion, preserved because phase mixing has not yet erased their dialect. Dust, too, has a memory. The infrared spectral energy distribution leans toward processed grains, smaller, shock-shredded particles that glow as embers rather than blazing torches. The paucity of PAH features and the softness of the mid-IR continuum match a pantry that was once stocked, raided by bursty star formation, and then warmed into reluctance. Without a robust molecular reservoir, the asymmetric lentil is easy for tumor stability to police. Raised epicyclic frequencies and mild AGN heating keep Q above the threshold, so the disk remembers how to form stars but declines the invitation. Gas refuses to read the old street map. Where ionized filaments survive, they sketch a rotation axis misaligned with the stars, a cartographer loyal to the last accretion rather than to the ancient plan. In places the gas nearly counter-rotates, a dynamical confession that it arrived on a tilted plane, lost angular momentum to shocks, formed a sprinkling of stars, and then thinned into transparency. Such misalignment is not decorative, it is a chronicle of angular momentum exchange, a record of how a spiral's orderly traffic becomes the polite congestion of a lenticular. The tidal palimpsest is generous to dynamicists. Fit planetary nebulae velocities in the halo and they extend the rotation and dispersion profile well beyond where integrated starlight can compete with the sky. Fold those tracers together with globular cluster kinematics, blue, metal-poor roamers wide and hot, red, metal-rich homebodies tighter and cooler, and an extended dark halo emerges, moderately concentrated and mildly triaxial. That shape naturally explains the isophote twist with radius and the gentle meander of ellipticity, while giving streams a cradle deep enough to keep them coherent for gigayears. As a citizen of a low-velocity group, the leonine oddball illustrates preprocessing in action. Relative speeds are small enough that flybys last longer, torque each other more effectively, and exchange gas without tearing disks completely apart. Harassment heats the stellar body, tides siphon or stir the gas, and the supply lines for fresh cold material thin. The result is a quiescent face with haunted margins, a system that looks settled at first glance but reads like an archive once the contrast is turned down. Distance, scale, and calibration conspire in its favor. Surface brightness fluctuations in the near IR place the shell-embroidered remnant at a distance where 1 arcsecond maps cleanly to a few hundred parsecs, fine enough to resolve kinematic twists, broad enough to trace debris loops across wide fields. Planetary nebula luminosity functions cross-check that latter and, as a bonus, carry kinematics into the realm where globular clusters roam. With those rulers set, the timing of the last significant encounter is not guesswork but geometry, shell spacing ties to orbital periods, and the observed dispersion clocks how many wraps have passed. If the hybrid relic ever carried a strong bar, its fingerprint lingers in subtler statistics. Boxy isophotes in the inner light, faint X-shaped residuals after subtracting smooth models, or a modest sigma drop where cooler, bar-fed stars settled, each would be a fossil of non-axisymmetric structure that once funneled gas inward. Bars fade when gas runs out and disks thicken, but the resonances they imprint can trap orbits long after the visible scaffold dissolves. Such memory explains why some orbits remain unusually ordered inside while the outskirts prefer a more democratic mixture. Future tools will turn this misfit into a reference atlas. Wide-field surveys will catch ultra-faint plumes and satellite knots, letting shell spacing statistics time the last splash with better precision. Space-based imaging will carve crisp population gradients to the effective radius and beyond, isolating intermediate age tracers that pin down when each ring of the mosaic was laid. Radio arrays will decide whether neutral hydrogen has been exiled to the periphery or truly bled away, and millimeter interferometers will test whether the molecular pantry is merely diffuse and elusive or genuinely bare. Simulations already rhyme with the observed collage. Cosmological zoom-ins that sprinkle in 110 to 120 satellites on varied, inclined paths yield triaxial light, lambda_r profiles that rise and soften, embedded disky cores, and a nucleus that idles in a radiatively inefficient mode, maintenance rather than fireworks. Add a mildly cusped halo and tidal streams persist on human observing timescales, flatten the cusp and the debris geometry shifts in ways the data can arbitrate. In this sense the Leo stray is not just a curiosity, it is a calibration target for the grammar by which gravity writes. Project the narrative forward and serenity is the asymptote. The faintest filigree will fade below detectability, position angle twists will relax as orbital families blend, metallicity gradients will smooth a little more, and the central engine will keep its pilot light on. A wandering dwarf may add a marginal note to the outskirts, but no new chapter seems likely unless a gas-rich interloper arrives on a precisely mischievous orbit. Absent that, the tidal scrapbook will mature into the textbook S0 that its face already suggests. For now, the stellar chimera remains a masterclass in how to read faint light. Its shells are clocks, its clusters are compasses, its gas is a contrarian historian, and its nucleus is a thermostat. The lesson is consistent and candid, structure is biography, dark matter is the invisible author, feedback can govern with whispers, and the best astrophysics happens just above the noise, where patience turns ambiguity into evidence and an unassuming lentil confesses its turbulent youth in lines so faint you must learn a new alphabet to see them.